Okay. All right, guys. So Brandon shared with me what he did. I mean, he said he went over file I/O. I'm not really sure like what in file I/O he went over. So I kind of put together some slides, and since he didn't give me any to upload for you, some of you really like slides to have. And so I will upload these. Plus, I just wanted to talk to you a little bit, because I know Brandon's a good bit younger than me. Just a few years. Anyway, because remember, I'm no more than 21. I never grew up. So anyway, actually, he's older then, if that's the case. So anyway, I really didn't know what he covered, and so and I wanted to kind of give you a history or just talk to you a little bit about file I/O. So let's go first, because Mondays are my days to kind of make sure we're all on track for labs and we're on track for assignments and we're just kind of up on everything for the week, and especially being going on Friday. So in your lab 6, I had some TAs that sent me a message and said, hey, I really think that this is confusing, and I think that the students are really confused because it seems like this should be has a relationship between the nation having 50 states, and states all have certain number of cities, and so shouldn't the nation have states and have cities? And maybe they were even thinking about, having a 2-dimensional array to put that together. I'm not really sure, but having more of this have a relationship, right? And I wrote back to one of the TAs and I said, well, it really kind of just depends on where you're coming from, because everything in computer science depends. And so a lot of times the way you structure everything has to do with what your problem is. And so if your boss came to you saying you're going to run this program that's going to hold all this data and it's going to stay running on your system at all times and contain all of this, all of the stats for the city, state, blah, 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 right? Then maybe you might want to make this 2-dimensional array of states with all these different cities that contain all these different statistics. Because that would make sense. You're carrying it around through the duration of the program and letting the user interact with this thing. I am coming at this. So the way, in my experience as a computer scientist, okay, file I/O comes in 2 places, okay, or comes in really big. And actually in 3 places, okay. And so one of those places would be in the web internet area, okay. That's a huge area for file I/O, okay? Because trust me, Amazon is not carrying around with them in their program all this data, billions of, tons of information of data, right? I mean, they're not going to carry that around. So they're going to have that in a database, okay? Prior to what we know as now, like the SQL databases, MySQL, whatever is out there, that are either what's called relational, okay? So the history of files went from flat files, okay? It's pretty interesting. When I taught databases a few years ago, no one knew what a flat file was. No one had even heard that term. And I thought, what an interesting thing that nobody's heard of a flat file. And a flat file was like just a 2-dimensional type of Excel type of flat file that we used to pump out, comma delimited, space delimited. It was just a flat file, right? And that's what we called them. Flat files are still pretty important, okay? Flat files are still used by graphical programs, so your PDFs are flat files. They're a binary flat file, but it's a flat file that some program has to read, okay? You have flat files, so you have lots of flat files of graphical programs. Most of your graphical programs read binary flat files, okay? Then, and back when I used to program in Perl and all these other, you know, for the web languages, we would write flat files. You'd read and write lots of different flat files, but you'd have like a flat file for people and a flat file for states and some information. And you'd have all different kinds of flat files, and you'd pull and put information in all of these different ones. Then came about this area of relational databases, like your SQL and all of that, okay? And that was to help so that you didn't have to make those relations. You could put those relations in a database and it'd make your coding a lot easier, rather than on the coding side we had to do a lot of the relations. You had to go from the flat files, pull stuff, and put the relations together, really, to know you had the right information going with what. Now the big thing on the horizon, well, it's not on the horizon, it's here, is what are relational and object relational databases, okay? So now we have databases that push objects into the databases and take objects out of the databases, and these are the most widely used now ones, okay? So that is why Python, Perl even changed, okay? Perl went from being a non-OO language, they support OO now. Python's OO and used for web. You got lots of languages now that are OO languages used for web, because now you can push and pull objects into the database, which is really rather cool, okay? So I'm kind of coming at from that angle of what if you had a website like Amazon or something like that, to where somebody comes in and you know they're going to want to find some kind of object, because that's all your thing is all about, is about objects, right? You just don't know if it's going to be a book object, a tape object, or what tape? CD object. Okay, so I really date myself sometimes, but CD object or whatever it may be, right? And so you don't know. And so you just have this object that needs to polymorph, and you get that user from pull down, you get that information from the user by pull down menu, right? And that object morphs into something. Okay? And that's what I'm trying to simulate with you guys, is that idea that you don't know when somebody comes to you just always are displaying back that object. You're only really displaying back is one piece of information back to them, right? When you go and look at, I was just buying some Adirondack chairs, right? You go in and looking for Adirondack chairs, you're looking for something specific, and it's pulling back all the information on that Adirondack chair each time you click on that one that you have, that specific object you're looking at, right? And so that's the mentality for Lab 6. The mentality is that your problem is very different. The problem is now that your data's in a database, you don't carry around anything. All you carry around is that you know your user's going to want to see something on your website, okay? They're either going to want to see a nation, and they're going to want to see some kind of stat, or they're going to want to see, you know, a state or a city. And you have to think about what you need in your database, okay? Because you are also, so here's some part of Lab 7 too, okay? So Lab 7, to make you understand what I'm trying to ask you to do, you're actually going to pull this information, you're going to inquire this information from the user, and then you're going to pull it from the database, okay? Because your database has all these stats. I don't tell you how to set up the database, because a lot of times that's part of your job as well, okay? And so when you're doing this, you need something to know on that line that you're on, hey, I am indeed looking, because the first piece of information you need to know from your user is, are they even looking for a national, state, or city type of statistic, okay? And that's why I gave you that website, because this is kind of what I was hoping you would understand that I was trying to mimic here. And so if that's the case, what's the very first piece of information you want probably each line of your data flat file to contain? So, right, you probably wanted to say, hey, I am a line that talks about the nation. I am a pipe delimiter, okay? You can delimit whatever you want to, but I, for some reason, you know, took on pipes as my delimiter when I used to do all of this. So you have nation. Sometimes I'll go to commas, but pipe and commas are the main two. State, because you need some kind of key. You need to know where am I? Which one am I on, right? The other thing you're going to need to know is you want to start thinking about what needs to be in here. If my person said they want to pop or they want some kind of keyword, what am I going to do to say that this on this line is population statistics? Or maybe you want to put all your statistics on one line with a city, but maybe you do pop and then the pop number, then you do a delimiter and you do bachelor degrees and then the number after that. It's up to you how you set it up, okay? I'm not going to tell you that. That's part of your design and part of your learning process, okay? Sometimes some can be slower, some can be faster, all right? So you're going to need something in there to say what that stat is. You probably want a number there if you're going to do several of them, or that number could be at the end. It just all depends on how you're going to set this up. But when you're reading or when you're writing from a database, okay, you better know how that thing is set up. You can't go in blinded. You have to know what's called the metadata. How is that data set up? Okay? What is the structure of that data? What's in all of the columns? What is in all of the rows? All right? Even when you're dealing with a relational database like SQL, you still got to know all this information. All right? Got to know what they called things. Okay, so that's part of lab 6 and 7 where I want you to go with this, and part of this whole flat file. So you're dealing with what's called flat files, and flat files are either binary or they're textual. Okay, they can be either or, and you usually use them, like I said, in a graphical program. In which case they're usually binary. PDFs, bitmaps, GIFs, all that kind of stuff. They're all binary flat files. All right. The next place where you see this is in the web, but kind of this has gone away, okay? So there's not as much of this flat file stuff going on in the web anymore because there's too much pieces of information. But if you want to make yourself a really quick website, very easy to do this too. The other place where you see this is in the OS. Okay, so if any of you end up going into operating system development or anything like that, everything is set up as a flat file. If you ever want to go in at some point, so here, I'll show you. Okay, so since we're in the ENGR, you can go and look and see. You should have some kind of mail folder. Okay. See, we have a mail. Okay. So there's all kinds of stuff going on in here. Let me go into my mail folder. You've got an inbox. You have sent mail. If you have set up your mail to forward off of like the server and onto something else, you'll have other stuff going on. If you've used from engineer and sent things, there'll be stuff set up in here. In these files, I was thinking I had subscriptions in here, but I don't think I do because I think everything for me is set up on my eecs. Oops. Yeah, I don't have any. But you can see these are some folders I have. Maybe it's back in this one. Anyway, oh, there's the subscriptions. So here's something interesting, okay? So there's flat file, okay? Everything on Unix is flat files. Everything in the OS is dealt with as flat files. All of our file systems and everything else are set up in some kind of little folders, but or some kind of files, textual files that the operating system reads that are all flat files. So if you do operating system development, you are reading and writing from files all day long, okay? Because that's where everything's kept, are in flat files, all right? All of our usernames, okay? So these are just my subscriptions. So every time I go into Microsoft Inbox and it pulls stuff, it reads this Unix. I mean, this is what tells it, hey, what to populate this stuff with. Right? What are all my subscriptions and my subfolders in this area? So OS is one area where we do this a lot of. I mean, look at your BMRC file, right? That's a flat file. Use another resource file. So operating system development does a lot of this kind of file item. The other place where you see this done a lot, so I'm trying to let you know, because in case you're going, why the heck do we need to learn how to do file I/O anymore from flat files? Everything's like SQL or relational. They're databases. Why do we do this? It's kind of obsolete. I'm trying to tell you it's not obsolete. It's very much here, true. It's how a lot of things operate, okay? The other place where you see this, where I have dealt with a lot of flat files because they're not relational databases, it's too expensive, is with satellites, okay? Or in the scientific field in general. So our satellites that pull a lot of, you know, space data, a lot of climate data, atmospheric, anything like that kind of data that comes in from satellites just gets pushed into a server, into a flat file. What happens with it? It's just dumped straight somewhere, right? And then you read it, and you pull it out, and you do stuff with it and operate on those pieces of information because they're coming in so constant. Imagery in the biology field, right? The DNA stuff, all of that's flat files. Those images come in as flat files. We do, you know, we look at those images and we try to see how things are spaced apart or see the patterns in certain stuff, okay? So it depends. I mean, there's a lot of different fields in CS, but flat files are still very, very important, okay? Not quite as much on the web end, all right? So I know that's kind of a bad example for Lab 6 and 7, but this isn't a web database class either, okay? So it is very important. With that said, okay, there is something out there, a Unix utility, and the other class told me Brandon did not cover this. Did Brandon cover redirecting input and output in here? Okay. So one quick and nerdy way to do file I/O in Unix is to redirect your input or your output. So in other words, you don't do anything with your file streams or any of that kind of stuff. You still use your input and output streams like your CIN, your COUT. And what by default is your CIN? What's the default attached to? What's Unix default just attach that sucker to?
Terminal?
Huh?
Terminal?
Right, well, attaches to this, right? C comes from your keyboard, okay? What does COUT default attach to? Monitor, good job. Okay, so a lot of times we want that CIN or COUT to be from something different, okay? For instance, I saw this with your poker games. Your poker games, sometimes you guys came in and you went beyond the scrolling area. I could not go back up and look at what you needed me to look at because it was too far up above out of your scrolling history, okay? And sometimes you got to go real far back up into your program. So a lot of times I dump my output not to my screen so I don't have to deal with it by looking on my scroll history and how far that goes. I dump it into, I redirect my COUTs to a file. And then that way, I can cat or more, whatever you do, or less, or however you get through a file, and view the contents and go through that file, okay? A lot of times I'll do that if I don't want to deal with file I/O. I can do quick and dirty reading from a file as well, okay? So you can read or you can write to a file in either which case. So this is redirecting has all to do with what you are redirecting the default input and output to be. Another really handy tool is when you want to read, so when I want to redirect and I want to send a ton of PDFs to a printer, okay, I can redirect that output of those PDFs and say, send that output, I don't want to see it on the screen, but redirect it and send star.pdf, all these PDFs, redirect them to the printer, an LPR, because there's LPRs, they're also just another file, another directory on here, and you just say, send it to that, or it's actually, they're looked at as files. They're looked at it like that because you can redirect to them, and then it puts it out to the printer. Okay? Anyway, so there's lots of uses for this, to redirect your input and output. So let's at least look. Oh, I got to go your directory. So somebody had me modify this a little bit and change it so that they wanted to know, could you read several things from a redirect? So we changed it so that we could read a number and then a name. They wanted to know if it starts back at the very first one with every CN. It doesn't. It's just like a file, okay? So we're going to pick back up with the next one. So this is all we're looking at, okay? We're just saying here we want to get in a number. We're going to say enter your name. Then it's going to get the name. And then we're just going to spit the name back out. That's all we're doing here. It's very simple, okay? And so let's look at our name file. So I put a 23 in there. And my name, okay? So that's all that's in this file. So I can say redirect, push things, bring in my input from name and push it into a.out. So in other words, my a.out is going to take input into, so now you can kind of see where C in, C out got their stuff. Those things go into where they're going. Whatever. Okay. So a.out, this stuff right here, okay, from name is going into the program, okay? And so CNs are now all by default coming in from name. Okay, we've totally said don't bring it in from the keyboard, bring it in from name. We're redirecting it. We did not redirect the output. We only redirected the input. Okay, so I didn't have to enter anything. When it said enter your name, it's not getting it from the keyboard. It's going out to this file to go get this input. Okay, I could redirect to an out file. Now, what do you notice? My input is waiting on me. My output, I can't even see what it's asking me because it's in the out file. I know it's asking me for a number, so let's put in something, right? And then it's asking me for a name. Now, we should be able to more our out file. And we see that it did say enter your name and it wanted that. So anything that was in the C out is going in there, okay? But we don't have it seeing out any 3. Seeing was just the, so we couldn't see anything, and we couldn't, yeah, and it was just hanging out there. Okay, so if we do this again, it says file exists, and it's not going to let us do anything, all right? So it won't override it. If we want to append to it, though, you do have the, I'll make a whole different one. Then you want to append to it, you do the double, okay? And that says let me append, and in this case we could do for and dog. I don't know, something different, right? And notice it, yeah,
Can you override it? Because like I've done echo that. Right,
probably because the redirect will say there's an option you can probably give it if you ban redirecting of things. But yeah, it'll tell you if the file exists, and it won't override it for you.
What if we, so when we're inside the code where you see out .0, why wouldn't it let us just use one bracket if 2 is same append?
Oh, because remember that's a language detail. The syntax in there, syntax for Unix says 1, 2 is append, 1 for your language. Yeah. So even though C was developed in Bell Labs, where Unix was developed, I mean, they were developed in the same place. There's a lot of things that are very common. I mean, not common, but they, you know, the people communicated together. It was all out of the same place in Bell Labs. And so I think sometimes when you look at the two, you can see some things where they obviously had communication or had some idea of each other that they were using, but yeah. But remember, they are different syntax. Okay.
Yeah.
Okay. Now I can also, so I could read from name and output to. Well, let's. And we get that. So you can do several. There are also, from what I remember, and you'd have to look, there are little things, okay, that you give little options in here, and you put little numbers. You'll have to look this up, okay, because I have to look it up every time. I do not memorize this kind of stuff because I'm not a big systems programmer. But there are numbers, and one means standard out, one means erroneous, so there's like a 1 and a 2, and you can actually say, do you want your errors to go out to output files, but only good stuff comes to the screen. So you can redirect certain aspects of what happens. Pretty cool. And you just put these little 2s or 1s right here, and it says what type of redirection for what kind of stuff. This is not a Unix class. Go out there and look. I'm just giving you some hints of some easy things to do since we're on this topic, okay? And I'd have to go back and look. If you have Kevin or somebody who's an OS teacher all the time, they would know right off the bat, right? But I don't do that all the time. Okay, so that's the whole, and that's redirecting. Now, what I also, so here's a few things. So I've been doing kind of weird things today. Not like I'm not always, but it's going to start getting a little stranger in this class on some certain days because I'm going to try to pull in information. So if you look, I'm going to upload these slides, okay? And it's called at the very bottom, I'm going to start giving you more and more information on C because this is our last C++ program, this file I/O. You're going to do it in C++, but this is it. We're going into C after this. So I do want you to start thinking about we're not going to stay in this language. And the stuff you are doing in this language is not going to work in the next class, okay? Such as C in and C out. Not going to work in the next class, okay? Here, this is C's equivalent to I/O stream, okay? C++ was their default input and output is I/O stream. That's their default library, okay? In C, it was, don't call this studio. Don't put that in your head because then you'll write it, okay? And sorry if I'm now making you say that, but it's standard I/O, standard IO.H for your C, okay? So it's your standard I/O, and this is what you have to use for C. You now have scanf and printf, okay? Scanf is like your C in, okay? Printf is like your C out. I really like C because if you were to go, so now's a good time to make you guys over the summer or even while you're in this class on the next assignment, I have in here useful links. Go to this book. This is the C Programming Language book, okay? It will help you tremendously. And if you go to the end of this book, it tells you all about these placeholders. I don't know where it's somewhere in the appendix. See, I don't know where, but it tells you somewhere in here what these mean. I want you to start looking at this book, okay? It's the very first link under C and C++, okay? When you're in that link, go and look up what all of these placeholders mean, okay? It's really nice. You know how you feel like in C++, CN, there's not anything in our book, and I've looked, that gives us a good description of where our cursor leaves off when you're reading data. Because where it leaves off when you're reading a string, where you're reading a line, where you're reading a character, where you're reading a number, where you're reading a decimal, where you're reading, they get different, okay? In C, it was very, very explicit. These placeholders are very explicit on what they do and where they leave your cursor, what they read before, what they ignore, and everything else, okay? C is very explicit, partially why I like it. You also list all of the different types of things. So %S is a string. So this is a string, okay? You have things like %C is a character, okay? %D is a decimal, not floating point number, as in decimal base number, okay? Now, you can use a %I for this, but don't, because you're a baby if you do. I see too many people decide they want to. Y'all are like, what? You are. You're kind of whippy. You're taking the easy way out. Lots of people do %I because they can remember that as integer. Remember, we have an F for flow. %F is our flow. %D is decimal. That's our base. Most of us write in C. We really look at, we don't do %I. I promise you, we don't do %I. We do a lot of %Ds, okay? Whether you take that advice and you do it or not, you better know when you're reading somebody's code, when you read a %D in C, it's not a floating point number. It's base 10, decimal number. That's what the D stands for, that kind of decimal, okay? The other thing I like about this, you know in your C-outs how you have to break it up? So you'll form your own opinion, guys, on whether, and I'm guessing my ECEers are probably going to like, you know, they're probably already like that we're done with all their OO stuff. But anyway, they typically like C a lot. I like this because look at how I don't have to break up my thinking. I can say, hey, I want to do all of this particular, you know, I want to keep on going with this string of text. And in these places where I would need to put my variable so that it prints out right here, I don't have to break my line of thinking. I just put a placeholder and say, I know I'm printing an integer here. I know I'm printing a string here. And then I will follow my string of text with what those things are. Syntax is a little different. It's very different, okay? But anyway, it is what it is, okay? In here, the other thing I want you to think about, okay, I don't care what language you use, okay? Typically, most languages, I'd say most, maybe I shouldn't say any language, but most languages that you use, you have to bring in some kind of library that lets you read from a file, okay? The next thing you have to do is you have to, if you're in an OO language, then you create an object, okay, a file object. Otherwise, it's a file pointer, okay? So in C, it'll be a file pointer, but since we're in OO, it's an object, okay? But you got to have something that's attached to that thing, okay? That you're saying, here's to attach to this stream, here's attached to this file in general, okay? Then you say you want to open. So you always have to do this, you do this, then you open your file. Some people put these together because you could say input.open on the same line, but they are two different things, okay? They're two different operations going on behind the scenes. And so as an example, if you wanted to create a number and you said, hey, I want to read from the input stream, open it, read that text, and this is how you would actually read from the input file into that number, okay? So if you go and look at those extra slides, I made these so that they mimic each other so that you could put them, if you want to, put them side by side, and you can see exactly what the same thing you do in a C syntax for the C++ syntax, okay? The other thing I want to talk to you about real quick is that if you want to, when you open for output, okay, you can open up your output stream, open it up. If you don't specify anything, it overwrites. If you need it to append, you have to say, I need this IO stream to be open for appending, okay? And by default, it's not open by appending. Closing, you want to close your file. This will also push anything out that you have left in your buffer into your file if you do have anything left over. Now, after the end of your program, it will close. I mean, you will be able to open the darn thing again. It's not like something crazy is going to happen, okay? But get in the habit of doing a close, okay? Just like you get in the habit of doing a delete, even though, you know, a memory leak's not going to go on forever once your program's done, right? It still is a good habit. All right, so you want to check to see if it fails. We care about this on input. Output we don't care about because if it's not there, it'll create it, okay? Input, if you're trying to read from file 1 and you don't have a file 1 and you just have a file.txt, it's going to fail, okay, when you try to read from it. Make sure that you have opened that thing correctly open before you read from it. End of file. Okay, there's a little something called an EOF at the end of your file. In C, there's a pound define a macro for EOF. All right, you just look and see if it's equal to EOF. In this one, we call a function to see if we keep doing something while we're not at the end of the file. If we're at the end of the file, it will return our true. Okay. So if we're not at the end, it will return false. And then we turn it true and do what we need to do. Okay. You could actually bring this up into here, and that will fail if indeed it was at the end of the file. Okay. So you could do one or the other, but I'd like for you to know that there is something special out there called an EOF, an end of file. Okay. Now, there is a way you can open them reading and writing at the same time. And really, that's about it. I mean, file I/O is really pretty simple. Now, I need for us to look at this, okay? We'll come back and write this too, okay? Because I found some interesting things because writing these templates and stuff. But right now, I need us to focus on this question right here so that you can get started with your assignment 4, all right? Because many of you are very confused as to what to do with that. So take just a minute. I am going to bring this up. Oh, where are we? Okay. If I end up writing stuff down here, can most of you see this? You can? How many of you are a little lost with this assignment? Yeah, the file I/O stuff, I know that. I like to teach all other stuff because file I/O is such a simple thing. I kind of like to do some other stuff. And actually, y'all will have fun with it. Okay, guys, because really what I want you to write out here in just a minute. So you've gotten together with some of your friends and everything, okay? First, let's talk about this, okay? And then what I want you to write down on paper with your friends is what I want you to solve for. Because I need you to solve for this right here, right? This thing right here, okay? Let's talk about what everything means here. All right, so what are we dealing with, guys? What are we trying to find the heat diffusion of? A wire. Wire? There's our wire, okay? It could be copper, it could be nickel, it's some kind of medium, right? We don't know what this thing is. It's of some length. It could be in meters, it could be in inches, it could be in millimeters. Say it's in the computer, right? I mean, you just don't know, right? Make sure your units stay the same on stuff. That's what you want to keep right, okay? Because we don't have units in the computer, but we make sure our units are correct that we're dealing with in our program. Okay? All right. So, this is, you can think of this is our wire. How does our wire start? How does it begin? First of all, what is you? What is you referring to? Yeah, everybody, that's the biggest question in this thing is, what is you? What is you?
The element itself.
You is the wire. I would think of you as the wire. Okay? I don't know if that's the right way. Y'all can correct me here in a minute if you think of it a different way. Okay? I think of you as the wire. What is T? Time. Where do we start with time? Okay. What is X? It's the intervals. What is, there should be an N at some point somewhere along the line. If I said N, what would be N? Number. Okay? And so your X is what? Where you are on this interval. Okay? Are we ever looking for X at 0? No. What is X at 0? Or what is U at 0? U of X. What is the wire at 0? That's right. I would just put it at 0 degrees, right? What is, and at the beginning, what did we do? We stuck it all at 0 degrees, right? And then what did you do to the end? Put some heat on it? Okay? All right. Still you. When you write it like this, does you look awfully like a one-dimensional array that, you, sub, except I'm putting it not an open bracket, it's just closed, right? 0. Oh my goodness, I just didn't close it and I put it at N. Okay? So we're never finding at 0, we're never finding at our N. You told me we have some certain number of these, right, which is this N. So if you had 100 and you divided it by 10, or you want to split it up into 10, then you're going to have 10 of these, right? You're going to have, this will be at X of 1, X of 2, X of 3. So we're never interested in this one, but we are interested in 1 through N minus 1, right? Are those what we're interested in? What do we use at this place to get that value? We use this side and we use this side, right? Okay? What are we interested in? This is set in stone for us. What are we trying to find?
Change.
The change. So we're trying to find that T plus my delta T, and we're looking at U at that place. We don't care about 0. It is set in stone. We don't care about N. It is set in stone. Okay? So this is U at T plus delta T. If I were to ask you to solve an equation of A over Y X, and I said solve for A, what would you tell me? Right, X times Y. Solve for that. Solve for this in your equation. This is A. There's A. Don't know what to do when I give it to you simple like that. There's A. Oh, solve for A. There's my term. There's my term right there. Right here, guys. In this equation, there's my term. This needs to be on the side all by itself because I need this, then I need this, then I need this, then I need this. And what am I using? This one was u of t. This is u of t plus delta t. Just like get a by itself on this side of the equation, get that u of x t plus delta t on one side of the equation. Do it now so you can work on it. Should be able to get it on one side of the equation. It's good old math, guys. Don't get ready for the college. I don't know why when I give it math for it, everybody knows and say, oh, why times that? So they don't know the other thing. Good old math. Good old math.
Did you throw it on the ground?
Instead of doing that, we just cancel out what's the time for
Sure.
Well, I will get, because you need some kind of letter on the board.
I found this only yesterday.
Can you tell me more, like what I am, what kind of letter do I need to be writing? Are these mine? Okay, awesome. What kind of letter do I need to be writing?
It doesn't take me, it's just give a fax email. This for this one.
Oh, those are so much easier too. So yeah, so put my name down. Go ahead.
Okay.
And if they can send it to me tonight, I can certainly have this done for you tomorrow or Wednesday. So the due date's Wednesday, right? So as long as I have it done by Wednesday, we'll be golden. Yeah, go ahead and put my name down. The forms are a lot easier because I don't have to get it all on letterhead and I don't have to get it back to you and all that. I can just fill out those little forms.
Okay.
Okay?
Thank you.
Yeah, you're welcome. Okay, let me make sure I have. Oh no, A, no, I said for A. I was trying to have, when I give y'all a simple one, like A over Y is X, and I said sorry for A. Y'all do the multiply Y over here, multiply Y over there. When I give you a difficult one like this, they'll start going, what the heck are you doing? It's just multiply, double T over here, multiply over there, divide by C, T over here, divide by C, T over there, plus U, T over, U, T, X over here, plus it over there, and now you solve for that, which is your new thing using your old data, so now you're because they're two arrays, right? And you're looking at the new array, and you're using your old array. Or you could call it U delta T.
I did. It was,
U delta T, right? That is this. That's how.
You know,
Yes. So what happened is this stuff, the approximation, is you, right? This thing right here, and so you're saying your older. Yes. Yes, and these H's are really time because that's what we're looking at is the change in time on that medium. And so when you plug it all in, you get this, the second derivative for the first derivative for the approximation, and you plug all this in. Yeah, so notice these are, the heat diffusion is based on derivatives, but it's based on first order and second order. Right? And so I'm just showing you when you need a first order derivative right here, the equation for first order derivatives for finite difference approximation is this.
That's what that word
stands for? Yes, and this little double prime means your second derivative. We do it like that's the only way I know how to code it like that. And your second derivative, when you do finite difference approximation for it, for second derivatives, is this equation right here. And heat diffusion means transfer of rate in is same as out, and so you have to set your first to your second. And then just by plugging things in, you get this thing down here.
It's like a sequence, right?
Yes.
To get UX class 2, we need UX class 1 UX.
Yes, yes, exactly. It's a sequence. That's exactly right. Yes. I did not stop my recording, so I'm over here gabbing and